Alright, so this is the graph of velocity with respect to time and acceleration with respect to time. Once again, I'm going to ask you to take a few minutes, look them over, and see what you notice that's different about the two. I'll hold my breath. Hopefully I won't hold my breath too long. Okay, so what's different and what's similar? Frequency is still the same. That angular frequency is not changing. It's one thing that hasn't changed over the entire thing. That omega is still omega. It hasn't changed. Okay? So if you can barely read that, that's omega t in there. If you're wondering what happened to the phi, I just treated it as 0. Just was like, I don't want to worry about the phi. I just want to do the graphs. Okay? Cool? So, that's what's similar. What's different? Everything else. It's at a maximum value here when acceleration is at 0. Okay? So, once again, we're looking at that up and down, up and down, up and down. We related acceleration to be at 0 at the same time position was. If you don't remember that, go back and look at the previous video. So right here, the acceleration is equal to 0. Velocity is at its maximum. It's as big as it gets. Because as soon as it travels beyond that equilibrium, there's an acceleration down. Which is going to say, well, velocity is in this way, but my change in my velocity per unit of time is this way. So for every little bit of time, it's going to get smaller and smaller and smaller and smaller until it reaches the top. Okay? And then my velocity turns negative and goes in the opposite direction. Cool? So, boom! Right at the middle. Velocity is at the maximum. Acceleration is 0. Okay? Cool? Other thing. Velocity 0. Top. The very top. Acceleration is negative, down. Maximum position, or maximum velocity is equal to 0. Okay. Which means it's either at the top or the bottom. If it's at the top, which means it's positive position, that means the acceleration is in the opposite direction. My position is up from the origin. I'm pointing towards the object. My position is up. My acceleration is down. So looking at this graph, I've got a 0 value. I've got a downward pointing acceleration. I'm at the top. Move over to the next one. I'm at about 0 point negative velocity. I'm out going my way down. Okay? So there's my graphs. It's really kind of cool. Simple harmonic motion is like the coolest part of kinematics. Okay? Typically you study simple harmonic motion as a separate area. But what I thought about, what I'm doing is I'm going to talk about the motion, and then I'm going to talk about the causes of motion. That's why I'm doing it a little differently. Okay? So, that's my plot of velocity with respect to time, my plot of acceleration with respect to time. Once again, I should have also pointed out the amplitudes, the peaks here, are different sizes. You'd expect your acceleration to be slightly smaller than your velocity, normally. Not always the case, but normally. Okay? Cool? That's simple harmonic motion for now. Okay?